Imagine one support assistant failing in 3 different ways. It quotes last quarter's refund policy. It breaks the CRM's required JSON schema. And it misses one critical clue buried in an 80-page case file. Those look like one AI problem, but they are 3. The policy is an evidence problem. The JSON is a behavior problem. The case file is a working set problem. Fix the wrong layer, and you can spend weeks fine-tuning a model that simply needed the right document. Or you can build a retrieval stack for a file that already fits in one request. In 2026, 1M-Token context is real, while vendor fine-tuning strategies are splitting. So here is a 5-question decision guide for choosing RAG, fine-tuning, long context, or a deliberate hybrid. First, an important update before the architecture diagram. OpenAI is winding down self-serve fine-tuning in stages, with training access narrowing through January 2027. That is a platform decision, not proof that fine-tuning as a technique is dead. Google's current Gemini documentation still describes supervised, preference, and continuous tuning for supported models. At the same time, some current Gemini and Claude models advertise context windows reaching 1 million tokens. But context capacity is not the same as reliable attention across every position. The tools are evolving, yet the underlying decision has become simpler. Ask what must change: the evidence, the behavior, or the working set available for this request. Long context changes the request. It places more documents, examples, history, or code inside one inference without changing model weights. RAG changes which evidence enters the request. It searches an external corpus and selects a smaller set of passages for the model to use. Fine-tuning changes the model. It updates parameters, so a repeated pattern becomes more natural and consistent. These are not mutually exclusive products on a winner-takes-all scoreboard. They are different levers, and strong systems often combine them after each lever earns its place. Start with long context when a working set is bounded and fits comfortably inside the effective window. Think of one legal dossier, one code-based slice, one meeting history, or one long research packet. This is especially useful when the question depends on global structure rather than a few obvious passages. The contradiction in Chapter 2 may matter only because of a promise in Chapter 11. Retrieval can miss that relationship when no local chunk looks important by itself. Full context is also a fast prototype and a strong mini-shot baseline. If the same prefix repeats, prompt caching may reduce cost and latency on supported platforms. But caching does not remove those tokens from the context window, and it does not improve attention by itself. Now subtract system instructions, tool definitions, conversation history, retrieve text, and the output budget from the advertised window. That remainder is your usable working set, not the number on a model card. Google's long context guide also shows that multiple needle accuracy varies by model and task. It warns that longer requests generally increase time to first token and recommends avoiding unnecessary tokens. So there is no universal threshold where long context suddenly becomes the correct answer. Test your own positions, document lengths, latency targets, and failure costs. Choose RAG when the corpus is larger than the effective window, changes frequently, or must be scoped per user and query. The refund policy is the clean example. Store the approved policies with region, date, version, and access metadata. At query time, retrieve the passages that match the customer's jurisdiction and transaction date. Now the answer can carry the evidence and an auditable source trail. But RAG is not a truth machine. It can retrieve the wrong version, split an important definition across chunks, miss an acronym, or lose a multi-hop connection. It also does not guarantee correct citations, source freshness, or authorization isolation unless you design and test those controls. That means retrieval quality and answer quality need separate scorecards. First, measure whether the system found the required evidence. Then ask whether that evidence was sufficient to answer the question. Only after that should you grade the final answer for correctness and attribution. Google's sufficient context research makes this separation explicit. Relevant passages can still be insufficient. This is why a higher similarity score is not the same as a solved user task. Choose fine-tuning when the right evidence is already present, but the model repeatedly fails the same behavior test. The broken CRM JSON is a behavior problem if the schema is clearly provided and the model still violates it. Other common candidates include stable formatting, classification, extraction, tone, instruction following, and tool call patterns. You need representative examples of the exact behavior you want under the conditions where it fails. You also need a held-out evaluation set before you train anything. OpenAI's own supervised fine-tuning guide says to establish good evaluations first. That sequence matters because tuning can make a behavior more consistent without making facts more current. If policies change weekly, need citations, or require fast rollback, storing those facts and weights is usually the wrong first move. Mini-shot prompting is a useful baseline before training because it tests whether examples alone can teach the pattern. If that works, but repeated examples make every request expensive, tuning may later improve efficiency and consistency. Platform support is now part of the operational decision too. OpenAI's self-serve path is shrinking, while Google's current platform still offers several tuning methods for supported Gemini models. So verify provider availability before committing, but do not confuse one vendor's roadmap with a universal technical verdict. Here is the 5-question decision tree. Question 1. What exactly failed? If the answer lacked or used the wrong evidence, investigate context and retrieval before changing weights. If the evidence was correct, but the output behavior was repeatedly wrong, establish a fine-tuning baseline. Question 2. Does the complete working set fit comfortably after every other token obligation is counted? If yes, and the task depends on holistic relationships, test full context first. If no, retrieve, summarize, or route before the request becomes an attention stress test. Question 3. How fast does the source of truth change? Frequent updates, versions, permissions, and rollback needs point toward retrieval. A stable behavior specification supported by durable examples can point toward fine-tuning. Question 4. Does the task need the whole structure or a few local passages? Narrative coherence, cross-file dependencies, and implicit global questions favor a long context baseline. Local, explicit questions over a large corpus favor a retrieval baseline. Question 5. Can you prove the gain on the layer you changed? No label behavior set means you cannot justify tuning. No retrieval recall and sufficiency set means you cannot justify RAG. No position, multiple needle, and latency tests mean you cannot trust a long context claim. The compact rule is this. If evidence changes, retrieve it. If behavior repeats, train it. If one bounded working set must be understood as a whole, place it in context. After those baselines, a hybrid can solve the original support incident cleanly. RAG supplies the current refund policy filtered by region and date, with a source the agent can cite. Long context holds the active case dossier, conversation history, and selected raw passages for this investigation. A tuned, possibly smaller model produces the CRM JSON and routing decision consistently. Explicit questions can use retrieval, while global or ambiguous cases can escalate to a fuller context pass. This is routing by task shape, not architecture by fashion. Before adding agentic search loops, test 2 boring baselines: full context read and simple retrieve then read. The Lara study compared many retrieval and long context combinations and found no universal winner across its question-answering tests. Other studies suggest simple order-preserving retrieval or self-routing can help in particular settings, not that either always wins. Treat those papers as evidence to run your own comparison, not as a product recipe. Finally, measure each layer separately. For retrieval, track recall, context sufficiency, source freshness, and permission leakage. For answers, track correctness, grounded attribution, and calibrated refusal when the evidence is insufficient. For behavior, track format validity, tone, classification, tool compliance, and regression on unrelated tasks. For operations, track latency, input volume, cache hit rate, update time, rollback time, and cost per successful task. The metric is not how impressive the architecture looks. It is whether the smallest changed layer fixes the measured failure without creating a worse one somewhere else. RAG is the librarian. Fine-tuning is the training. Long context is the desk. Most production systems will eventually use more than one, but very few need all 3 on day 1. Do not ask which acronym is winning. Ask what must change, the evidence, the behavior, or the working set. Then test the smallest system that changes only that.